Hey Opties! Today we're talking about triangles. Specifically, the sum of their interior angles and how to find the measure of one exterior angle if you know two non-adjacent interior angles to that exterior angle. First of all, I want to show you a little demonstration of how we get to know the sum of any interior angles of any triangle. Okay, so here is a picture. I know this looks weird with the letters upside down, but it will help us see it a little better once I do the demonstration. So we've got three angles, A, B, and C. Okay, so what we're gonna do is cut this triangle out, and then we're going to cut out each angle. So I'm just gonna cut it like here, here, and here to get these angles. And then what I'm gonna do is I'm gonna line them up and they're gonna make a line. What kind of angle does a line have? It's a straight angle, so it's 180 degrees. So that's what we're gonna see. Here is a triangle. Okay, I'm gonna cut each angle like this. There's one, and I'll do it like this. It won't really matter. I could have cut it in half like it was. So we don't really care about this little inside triangle. We're kind of cutting out the middle part of the Triforce if you're into Zelda, you know. Okay, so there's A and C. Let's put it in order just to be cool. A, B, C. Now, look what we've just created, a flat line. Okay? Flat line. That's 180 degrees. And notice, we've got angle A, angle B, and angle C. So when you add up those three angles, you get 180. This is true for any triangle. So you could just draw a triangle at home, cut it out, cut out the angles, put them together, and you'll see that it's a straight line. So let's look at our definition here, and I've also drawn out a picture here on the notes to represent what we just did. So angles on the inside of a polygon are in this case a triangle. That's the definition of our interior angles. The triangle angle sum theorem. Sounds so fancy, right? It's just telling us how do we know what the sum of the interior angles of any triangle is. So it says the sum of the interior angles of any triangle is always equal to 180 degrees, meaning they are supplementary. Remember, supplementary is our vocabulary term to describe when angles added together equal 180 degrees. So we can say they're supplementary. Here's what we can do to verify. If you draw a triangle, cut it out, and put all the angles together, they'll make a straight line which shows that they make 180. And that's exactly what we just did with our paper. So let's take a look at our picture. Here we have ABC, the triangle ABC, and then we see that if we cut them off, you see these little squiggles mean that you cut that off just like I did. And you line them up and you get all three of those angles added together, all are 180. Now I do want to talk about one thing. You know how we talk about the same number of arc marks mean that that's a congruent angle? Well, this is actually not showing congruence here, but just to make sure we're not confused, I'm gonna draw the different number of arc marks so we know that those three are different angles. So just because I had one arc mark, I was just showing that the angle is being measured, but it doesn't mean they're congruent in this case. So a better picture would be to draw it like this to show that they're not congruent to each other. So I might do another arc mark on the A and then two on the B. And a little dotted arc mark is just showing that we're measuring all three of those angles together. See how that dotted arrow goes with that dotted arc mark. Now, let's take a look at exterior angles. Exterior. When I hear that word, I think about like HGTV, you know? They're like, let's take a look at the exterior, or like exterior paint. I don't know, maybe I'm weird. The exterior means outside, right? Interior design. You're looking on the inside. So that might be a good way to remember the difference there. So definition, angles on the outside of a polygon, or in this case, a triangle, that are formed by extending, think about extending your arm, or extending whatever, getting longer, right? But you're starting from where you already are and just making it longer from what it already is. Extending the side of a polygon. So we're gonna see that in our picture here. Here's our theorem. The exterior angle formed when you extend the side of a triangle is equal to the sum of its non-adjacent angles. Whoa, non-adjacent angles. That's like kind of a lot of vocab right there, right? And extending, we got a lot of vocab happening. So let's just take a look at this first picture, which really gets us to understanding why we have our theorem. So we see that these orange arrows are pointing to the interior angles of the triangle. And we know those add to 180 degrees because that's the interior angle theorem. Interior angle sum theorem for triangles. We also know that these green arrows that they're pointing to these two angles, these add to 180 as well, these two orange angles. And the reasoning behind that is because these two are a linear pair. Linear pair, remember, a linear pair is when two angles are supplementary. We can tell that they make a line because this orange little chunk here, that's a line. I mean, technically we could have our little arrows here, but you know it's flat, it's gonna be a straight angle. Let's also make our note that this is the interior angle sum theorem. I'll just do THM for theorem. Let's take a look at our second picture. This is kind of writing in words what our theorem means. So notice it says these two non-adjacent angles, now they are non-adjacent to the exterior angle. They are adjacent to each other. And remember, what does adjacent mean? Adjacent just means beside. So the angle that will be beside this exterior angle is this guy right here. So these are not beside this exterior angle. So they're the non-adjacent. So let's go back and look at this picture, our first picture. You see how there's an overlap of arc marks on this angle? Because it's shared with the interior angles and it's also shared with the linear pair. So if you subtract that, if you just take it all the way out, you would have this orange angle equaling these two green angles, okay? So let's just pretend that this is A, B, C, and D. So we could say the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees, right? Interior angle sum. We can also say this. The measure of angle C plus the measure of angle D is 180 degrees. Now let's say we want to subtract the measure of angle C from both of these. So let's do that. Let's subtract it from both sides on both equations. So now that becomes a 0, and then we just have the measure of angle A plus the measure of angle B equals 180 minus the measure of angle C, okay? Now if we subtract the measure of angle C from both sides of this equation, then we have the measure of angle D is equal to 180 degrees minus the measure of angle C. Now look, this side of this equation is the same as this side of this equation. Let's put a little degree symbol there. So if those are the same, then that means the measure of angle D equals the measure of angle A plus the measure of angle B. So let's write that. The measure of angle A plus the measure of angle B equals the measure of angle D. So this was like our D and this was like our A and our B. So we can see that if you add up these two dudes, it'll equal this dude. All right, that's it for our interior and exterior angles of triangles. See y'all next time.